we studied that electron has a dual nature, means it behaves both as a particle and as a wave. Hazelnut, when he studied, he found that macroscopic particles behave as the particle only, whereas the microscopic particles behave as wave particles, means all the microscopic particles have the dual nature, means they have the particle nature also and the wave nature also. Similarly, electron also behave the wave nature and the particle nature both. Hazelnut, for this purpose, Hazelnut proposed a principle which is known as Hazelnut uncertainty principle. According to this principle, the position and velocity or position or momentum of a particle is not calculated accurately at the same time. Means if we want to calculate the position of the microscopic particle and their velocity or momentum together, it is not possible accurately, as the value of the product of the position and the momentum of the microscopic particle is either greater than or equal to h by 4 pi. If we change this p, this momentum, where delta x is the uncertainty in the determination of position and delta p is the uncertainty in the determination of momentum, so their product is either more than or equal to the h by 4 pi. If we change this, we put the value of p, is momentum, which is m into v, we get this equation, delta x into delta v is either greater than or equal to h by 4 pi m, where m is the mass of the particle and h is the Planck constant. For electron, the value of delta x into delta v is either greater or equal to the 0.579 second per gram. Wave nature or quantum nature of the electron is explained by the Schrodinger wave equation. This time in your syllabus, only you have to learn what is Schrodinger wave equation, only the equation. Derivation is not in your syllabus. And the psi and psi square and psi is also, this is not in your syllabus, but psi, the Schrodinger wave equation is del square psi plus 8 pi square m by h square e minus v psi is equal to 0, where del square is equal to del square by del x square plus del square by del y square plus del square by del z square, where in this equation E is the total energy of the system, V is the potential energy of the system, M is the mass of the electron, H is the Planck constant, and psi is the wave function, that we can also say the orbital, means the amplitude of the wave, and psi square is the place or space where the probability of finding the electron is maximum. That place is known as psi square, gives that value. The reason around the nucleus where the reason in the orbital where probability of finding the electron is maximum, that is represented by psi square. Now, after this, I am going to explain you the quantum number. As when you have to give the identity of any person, for that it's required that you know to whom, the country to whom he belongs, the city in that country to whom he belongs, the street in that city to whom he belongs, and in the street the house number to whom he belongs. Means you require their ID. Similarly, quantum number is also the set of numbers which designate or describe the identity of an electron in a particular orbit. So, quantum number, there are 4 quantum numbers as they represent the shape, size and orientation of the electron in any orbital. Means first 3 quantum number is described by the Schrodinger wave equation, and they explain the shape of the orbital, size of the orbital, energy of the orbital and the orientation of the orbital or orientation of the electron in the orbital. They are known as principal quantum number that we represented as n, azimuthal quantum number that we represented as L, small l, and magnetic quantum number that is represented by small m, and the last quantum number is the spin quantum number that describes the orientation, means that describe the movement, spinning of the, not orientation, movement or spinning of the electron, whether the electron moves clockwise direction or anti-clockwise direction. So, the quantum number is the set of numbers that describe or designate the electron present in the various orbitals in an atom. So, by knowing all these 4 quantum number, it is easy to recognize the place of electron and the energy of the electron and the orientation of the electron in that orbital, because it describes the orientation in the space of the orbital also. So, let us start to study all these quantum number one by one. Now the quantum number, before teaching it, I want to explain the difference between the orbit and orbital. Orbit you studied in the Bohr's model, where the electron revolves in a definite path around the nucleus. But orbital is the region in the space around the nucleus where the probability of finding the electron is maximum. As orbital we speak in when we discuss the wave nature of the electron. So this is the difference between the orbit and orbital. Orbits are generally elliptical or circular in nature, so they are non-directional in nature, whereas orbitals have different shapes, as S orbital is spherical in shape, P orbital is dumbbell shaped and D orbital is double dumbbell shaped. So they have the directional, they are directional in nature. Means they orbitals are only S orbitals are non-directional in nature, whereas P, D, F orbitals are directional in nature. They arrange in the x direction by x, y and z coordination. Orbit is planar. It considers the motion of the electron in a plane, whereas the orbital is three-dimensional motion of electron around the nucleus. So let us start the quantum number. As in beginning I told you, quantum numbers are of 4 small l represent the azimuthal quantum number. It is helpful to describe the spatial distribution of electron cloud. Means how the electron cloud arranged in the space, and that decide their shape of the orbital. It is also helpful in describing the angular momentum of electron in an orbital by the formula capital L is equal to under root L inside the bracket L plus 1 h by 2 pi. By using this formula, we can find out the angular momentum of the electron in a particular orbit. Main thing is azimuthal quantum number is describe the shape of the orbital. Principal quantum number help us to find out the energy and the radius of the orbital. Azimuthal quantum number for any given value of n, principal quantum number, the value of azimuthal quantum number we can find out as for a particular value of n, its value azimuthal quantum number has the value n minus 1. So let us see what happens. If the value of n principal quantum number is 1, means K shell, the value of azimuthal quantum number L is n minus 1 means 0. 0 represent the S subshell. Orbital also the subshells are present in any shell, as you know, shell, and in that shell some subshells are present. Subshells represent by the azimuthal quantum number. So we also say the azimuthal quantum number as subsidiary quantum number or secondary quantum number also. So it also represents the subshell. It represents the shell. Now, if the value of n is 1, the value of L azimuthal quantum number is 0, which represents the subshell S. The total number of subshell in any shell is same as the number of n. As here, value of n is principal quantum number 1 and principal quantum number is first energy level. In that only one subshell is present. In second principal quantum number or second shell, two subshells are present. That we represented as 0 and 1 because value of L is 0 to n minus 1. So 0 represents the S or subshell and 1 represents the P subshell. There are two subshells in the second shell. 3. If the principal quantum number is 3, then the value of azimuthal quantum number is 0 to n minus 1. Means 0, 1 and 2. It means 3 subshells are present that we represented by 0 by S, 1 by P and 2 by D. Now fourth shell contain 4 subshells 0, 1, 2, 3 that we represented as S, P, D and F. So by knowing the principal quantum number and azimuthal quantum number, we can find out the size and shape of the orbital. Next quantum number is magnetic quantum number, as when magnetic field which we represented by small m. And one more thing, that the maximum electron present in the subshell, maximum number of electrons present in any subshell is equal to n 2n plus 1. 2n plus 1 as first subshell. The value of L is 0. So how many electrons are present? means 0 plus 1. 2 into 1 means 2. So only 2 electrons are present in the subshell S. In the subshell P, here I am telling subshell S, only 2 electrons are present. Subshell P, according to this equation, the value of N is 1. 2 into 1 plus 1 is 2 plus 1, 3. 2s are 6. So total number of electron in P orbital is 6. 2, 12 plus 1. Now for D orbital or D subshell, total number of electron in D subshell is, because for the D, the value of N is 2. So 2 into 2, 4 plus 1, 5. 5 2s are 10. So total electrons are present in D orbitals are 10. For F subshell, the value of N is 3. That's why this value will become 3 2s are 6 plus 1, 7 2s are 40. Means total 14 electrons are present in the F subshell or F orbital. So this, by this we can find out the azimuthal quantum number. Next is magnetic quantum number. Now the next quantum number is magnetic quantum number. As magnetic quantum number is when the magnetic field is applied, then the spectral lines are break down into several spectral lines, time spectral lines, and this effect is known as Siemens effect. Magnetic quantum number explains the orientation or distribution of electron in the space. For a given value of L, the value of M is represented as 2L plus 1. As for the value of L is written here, value of M, magnetic quantum number, and value is represented here. For value of L, if it is 0 means S orbital, the value of M is 1. Only one value means one orbital and we represented it as 0. If the value of L is 1, means according to this the value of M is 2 into 1 plus 1 means 3. So there are 3 degenerate orbitals are formed, that is 0 plus 1 minus 1, which also represented as Px, Py and Pz orbital. Px orbital are along the x-axis, Py orbital along the y-axis and Pz orbital along the z-axis. So threefold degenerate orbitals are obtained. If the value of L is 2, means D subshell, the value of M is 2L plus 1, means 5 degenerate orbitals are formed, which the value is given like this. These are the 5 orbital. Middle orbital we write the 0, this side plus 1, plus 2, this side minus 1, minus 2, and these orbitals are represented as dxy, dyz, dzx, dx square y square and dz square. In these orbitals, these 4 orbitals are along the axis, or they are in between the x and y axis. dyz, between the lobes are between the y and z axis, and in d orbital the lobes are in between the z and x orbital. dx square y square lobes are along the x orbital and y orbital. These orbitals are the double shape, means 4 lobes are present in these orbitals. dz square orbital, in this is the different type of orbital, and in these lobes are present along the, only 2 lobes are present. This is like this. Two lobes are present along the z orbital. This is the dz square orbital. F orbital, if the value of n is 3, then the value of m means magnetic quantum number is 7, means 7 orbitals degenerate, 7-fold degenerate orbitals are formed, which represented as middle one is 0. If we are moving from in this side, it is plus 1, plus 2, plus 3, this side minus 1, minus 2 and minus 3. So total 7 orbitals are formed. And each orbital contains 2 electrons. So just now you get the value that s orbital contains maximum 2 electrons. P orbital, because it has 3 orbitals, so it contains maximum 6 electrons. P orbital, because 5 degenerate orbitals are formed, so each orbital contains 2 electrons. That's why total number of electrons in this 10. And F orbital contains 7-fold degenerate orbital, means it contains 14 electrons. Degenerate orbitals means in the absence of magnetic field, these orbitals have equal energy. Now, shape of the orbital. S orbital is spherical in shape, like this. So it is non-directional in nature. P orbital, as it is, because wave nature, we are representing the orbital in the 3-dimensional, and this is x, y and z direction. X, y and z. X, y and z. X, y and z. So if we represent the px, it means lobes are present like this along the x-axis. Py, lobes are present along the y-axis. Pz, lobes are present along the z-axis. So it represents the px orbital, py orbital and pz orbital. Dx orbital, if we represent the lobes, because it contains 4 lobes and lobes are present like in between the, if we are representing the, if it is x, this is y. So lobes are present between the x and y orbitals. Like this. Similarly, we have to represent dyz, dzx, and if we are representing dx square, y square, then the lobes are present along the x-axis. This is x, this is y, along the x-axis and along the y-axis. So this is the shape of the different types of orbital. In case of F orbital, structure is very complicated, that you will study in next classes. Now the last quantum number is spin quantum number. Firstly, quantum number as given by the Schrodinger wave equation. This last spin quantum number explains the spin of the electron in the orbitals. As the movement is clockwise, we can represent it like this. Anti-clockwise, we can represent it like this downside arrow. So the position of the arrow shows whether the electron rotation is clockwise or anti-clockwise. For clockwise spinning, we represented it as plus half, and for anti-clockwise spinning, we represent it as minus half. So this is all for the quantum numbers. Next you will do the questions based on these quantum numbers. Now there are some questions. As first question, write the value of magnetic quantum number m if the azimuthal quantum number L is equal to 3. So if the L is equal to 3, the value of magnetic quantum number m is equal to 2, because 3 represents the d orbital. So value of m is equal to -2, -1, 0, +1 and magnetic quantum number, and if the azimuthal quantum number L is equal to 3. So for if L is equal to 3, it means it is the f orbital, as L is equal to 0 means S, L is equal to 1 means P, L is equal to 2 means D, and L is equal to 3 means f orbital. So for f orbital, we have 7 values, -3, -2, -1, 0, +1, +2 and +3. Next question. How many orbitals are present in third main energy shell? Third main energy shell means n is equal to 3. The maximum number of orbitals in this we can find out, as it is 3 means it contains 3 orbitals or suborbits or subshells S, P and D, and subshell S contain 1 orbital, P shell contain 3 orbitals, D shell contain 5 orbitals. So total sum up is 9. Maximum number of orbitals are 9 if the value of main energy shell is 3. We can also find out this value by n square. If we know the value of n, the maximum number of orbital in any shell is according to n square. So 3 square is equal to 9. So total orbital are 9. Next question. What are the possible value of L and m for d orbitals? For d orbitals, as it is given 4 d orbitals, means the value of 4 d orbital L is equal to 4. The value of L is equal to, as it is d orbital, so the value is for L is equal to 3. And for d orbital, the value of m is equal to -2, because 5 degenerate orbitals are formed. So -2, -1, 0, +1 and +2. 5 orbitals are in this case. The next question, 4th. Using the Spdf notation, describe the orbitals with following quantum numbers. First, L is equal to 1, L is equal to 0. If L is equal to 0 means it is the S orbital, and L is equal to 1 means 1 S energy. This is the next. L is equal to 3, L is equal to 0. Again L is equal to 0 means it is S orbital, and main energy level is L is equal to 3, so 3s orbital. For this, L is equal to 5 and L is equal to 2. L is equal to 2 means for 0, if L is equal to 0, S orbital. If L is equal to 1, P orbital. L is equal to 2 means D orbital, so it is 5D. L is equal to 3 means F orbital, so it is representing the 4F. the orbitals like Spdf, and n represent the energy level. For that you will write down 1, 2, 3, 4 before the orbital. Designate the next question. Designate the electrons having following sets of quantum number. If n is equal to 2, n is equal to 0, m is equal to 0, and s is equal to plus half. It means the electron is present in main energy level is 2. If n is equal to 0 means 2s orbital and having the spin clockwise with clockwise spin. Electron present in 2s orbital with clockwise spin. Next, if n is equal to 1, n is equal to 0, m is equal to 0, s is equal to minus half. It means as here again the n is equal to 0 means s orbital and n is equal to 1 means 1s orbital. The electron is present with anti-clockwise spin. Next question, if n is equal to 3, n is equal to 1, m is equal to plus 1 and s is equal to plus half. It means the electron is present, n is equal to 1 means p orbital, and because m is equal to 1, p orbital we can represent like this as 0, plus 1, minus 1 magnetic quantum number. This is px, py, pz. So px, which one main energy level is 3, and possesses clockwise spin. So the electron is present in 3s orbital and possesses